Let's now talk about the binomial theorem in very simple terms. So, what do we know about the binomial theorem? So, the basic idea is this: the coefficients that we've already talked about, n0, n1, all that. So, in a case where they want you to expand, we use a plus x in brackets, let's set the power n. Okay, the way you basically get to expand that is you start the binomial coefficients from n choose 0. So n choose 0, and then the first part, the other part will always be including a and x, so it will be a and x. Now their powers are to be dependent on the values in the brackets. What I mean by that is, in this case, your a is going to be the difference between n and 0, which is just like n minus 0, which is just like n. For x, it will be x to the power 0. For the other part, the second part will be now n, you now choose a 1. So if you choose a 1, your a will be the power. Now, a will always be like the power, the difference between n and r. So it will be n minus 1. And then x will always be matching up with the value of r on the bottom there. Try to guess what will be the next term there. So it will be n choose 2. A will be to what power? Now a will be now the difference, which is n minus 2. X will still match up with 2. Try to guess the other term. N choose 3. A will be the power difference. Then b, which is x, will just match up with 3 again to the power 3. And so on and so forth. That's basically the binomial theorem. So it's just built on the main idea of you working with the issues of the binomial coefficients. Now you understand what the binomial coefficients are. So each time you'll be counting in that way. Now I've already explained, actually in the next video I will explain how you basically get to find the specific nth term. For now, this is the basic idea about the binomial theorem. Okay, so how basically do we use this expansion? Now of course earlier on we saw that we can use Pascal's triangle to deal with simple expansions like 2 plus x. Let's set the power 2 even up to the power 3. It's very easy for you to basically expand that. Now I'll use a simple one to the power 2, which you're able to expand without any need of binomial theorem. So you know that that's the same as 2 plus x. 2 plus x. So if you try to expand that to simplify it, 2 times 2 is 4. Of course you have x squared plus 4x, I believe, plus 4. Now how would you handle that using the binomial theorem? So for the binomial theorem, remember in this case our a is 2, our x is our b, so our power is n. So when it comes to binomial theorem, you say your n is 2, and then of course always start from 0. So 2 choose 0. What are we going to have? So we're going to have the first part, which is our a, is our 2 there. Okay, it's our 2. So it will be 2. Now I said it is going to be the difference between what you have in the what you have as your binomial coefficients. So 2 minus 0 is just going to be 2. And then your b in this case is x itself. So x will be the power 0 plus. It will now be 2 choose 1. 2 will be the power. It will now be the difference. Again, 2 minus 1 is a 1. X will match up to 1. And then we have 2 choose 2. 2 minus 2 is 0. X will still match up with a 2. So I've already made the relation to say x will always be matching up with what is on the bottom in your coefficients, as you can see. And then the a part, which in this case is a 2, will always be the difference between what is inside there. 2 minus 0 is a 2, 2 minus 1 is a 1, 2 minus 2 is a 0. That's the basic idea. Now, of course, you know how to simplify what is in the brackets, right? But what I mean by that is the binomial coefficients. 2 choose 0 is the same as 2 factorial over 2 minus 0, which is just of course 2 factorial, and then 0 factorial. I already explained to say 0 factorial is equal to a 1. So these will just divide, giving us a 1. 2 times 2 to the power 2 is a 4. X to the power 0 is just a 1. So for the first part, the answer is just a 4. So this explains one concept which I'm yet to explain. Whenever you have got 2 choose 0 or any number choose 0, the answer will always be equal to a 1. Okay. X to the power 0 is also equal to a 1. So you just have a 4. Plus 2 choose 1 is 2 factorial over 2 minus 1 factorial, 1 factorial. 2 minus 1 is a 1. So on the bottom you just have a 1. On top 2 factorial. So this explains why whenever you've got any value and then you have a 1 on the bottom, it's always going to be equal to n factorial. To always be equal to n factorial. I believe. Is it n factorial? And we'll try it. I hope I'm right. If not equal to... No, it's always going to be equal to n or c. Yeah. So we have 2 factorial, which is of course in this case is just equal to a 2 times 2. 2 to the power 1 is 2, so it will be 4x. And then for the last part, 2 choose 2 is the same as 2 factorial. 2 minus 2 is 0 factorial, and then 2 factorial. This also becomes equal to a 1. It always be equal to 1. So we have 1 times 2 to the power 0 is a 1 as well, so you just have like x squared. So this guy is matching up with that part. Okay, so that's the way the binomial theorem basically works when it comes to expansions. Now there are three different things that I need to make mention of and explain them so that we can simplify the binomial theorem unlike the way we have it, because at the moment the way it is looking, it is appearing as n choose 0, a will be the power n minus 0, which is just like n, and then x will be the power just like 0, and then you have n1, a will be the difference, x will be the power 1, and so on and so forth. And then at the last point you should choose n out of n, and then a will now be n minus n, which is like 0, and then x to the power n, like that. Okay, so how do we handle this? We want to simplify this more than we have it right now. So what I'm trying to say is, if you look at n choose 0, that is the same as n factorial, and then the difference is n minus 0 factorial, 0 factorial. So that is the same as n factorial. N minus 0 on the bottom is just n factorial. 0 factorial is just a 1. So this will always be equal to a 1. So any value of n choose 0, or any value combination 0, it is just always going to be equal to a 1. Okay, now I want you to take note of that. So that is always going to be equal to a 1. Now the other part I want to talk about is n choose 1. This is the same as n factorial, n minus 1 factorial, and then 1 factorial. Of course 1 factorial is just equal to 1, so you have n. Now you can simplify that. It will be now n minus 1 factorial, so that it can cancel out with a n minus 1 factorial on the bottom. So any value of n choose 1 will always be equal to n. And then finally, when you have n choose n, it becomes n factorial. N minus n is just like 0 factorial. And then, n factorial, n minus n, and then n factorial itself. So you notice something as well there. That will always be equal to 1. So n0 and n choose n itself will always be equal to 1. So these are the three things that I want you to know. So they are going to reduce or simplify our expansion in this way. You are going to have, so n choose 0 is 1. So this will no need of writing that each time you're expanding. And then x to the power 0 is always going to be a 1. So that's why if you check some textbooks, the expansion comes out this way. It is at the power n plus. For n choose 1, you just see n. Okay, it's not necessary to show n choose 1 because it's always going to be equal to n. And then you have a n minus 1 x to the power 1 plus. At this point now, that's where it now becomes necessary for you to begin choosing now. N choose 2 at the power n minus 2 x to the power 2, and so on and so forth. And then of course for the last one, it just, that is equal to 1, that is equal to 1, so it will be end up with x to the power n as well. So that is the simplified form of the binomial theorem. Of course, in the next video I'll talk about the case where you have, where instead of having a, you get to have 1 plus x to the power n. Okay, how does that affect that binomial theorem? So usually that deals with the negative and the rationals. Okay, but anyway, we'll talk about that a bit later actually, because we have to talk about the certain practice questions that we might expect, things like the terms independent of x and how to deal with other things as well. Okay, so we now know what the binomial theorem is, and the easiest way to remember, I believe you've gotten it. Now, just for the sake of practice, let's say we use the same question I gave you. Okay, the power 10, right? So look at this question. So let's try to find a few terms of this. Let's try to expand this. So the way we're going to expand this is, now I never wanted to deal with the one where the value of a is equal to 1. Okay, let me deal with this one. Let's say we have 2y, 2x, okay, 2y plus x, let's say the power 3, and then you're told to expand that. How do you go about it? So using the binomial theorem, you can go take your a to be 2y. So in this case it will just be 2y. The power itself is 3 plus our n is 3, our a is 2y. Now as you basically get to notice, as you get to be conversant with this, you'll be able to see that your value of n is reducing by 1 at each point. Okay, so 3 minus 1 is just a 2. X begins to increase. Okay, plus. Now this is now where we'll be introducing the binomial coefficients. Your n is 3. You are choosing a 2. And then you have a. Your a is 2 what? 2y. Now at this point it is raised to the power 3 minus 2. which is now just like 1, and then your x will match up to be the power 2, and then for the last part you have 3 choose 3, which I already explained. That is just the same as just like a 1, but I will just show it for the sake of your understanding. And then 2y will be the power 0, and then x will be the power 3. So for the sake of your understanding, again, I can introduce in all the other terms. There's no restriction. So for the first one, it is always going to be choose 0. For the second one, it will be choose 1. Okay, which is 3 choose 1. And then of course x will match up with a value of r. So that's basically the way the expansion works. Now of course, with some of the things that I've taught you and I've already explained, instead of doing or showing all that, you can just simplify your work, because you know 3 choose 0 you will always be equal to a 1 irrespective of the value of n. Now 2 to the power 3 is 8, so you have 8y to the power 3. X to the power 0 is always going to be a 1, so not necessary to be shown, plus the second part where we've got 3 choose 1, it's always going to be a value of n, in this case which is a 3 itself. 2 to the power 2 is 4, so you have 4y squared x. You continue like that. 3 choose 2. Okay, so I also didn't talk about that. Whenever you're choosing something less by a 1, I believe it should just be 3 itself. So 3 factorial is 3 minus 2 factorial 2 factorial. So your answer will be 3. So you have a 3, 2y x squared, and then for the final part, that is equal to a 1, 2y is equal to 1, you just have x to the power 3. So of course that becomes 12y squared x. This becomes 6yx squared. So that's basically the way you basically get to deal with the binomial theorem when it comes to dealing with expansions. Okay, of course there will always be other things where it will be a bit difficult for you to simplify everything and expand and do whatnot, but basically we'll talk about the other forms of questions that you can handle. But all in all, with practice, this will not be difficult for you to remember that in a case where you have a plus x the power n, always start with n choose 0, and then a will be the difference of what is in the coefficients, and then x will always match up with a value on the bottom. Okay, so again a will be the difference, and then x will match up with the bottom, like that. You continue like that. Okay, so you continue until you reach n choose n. That's the binomial theorem. Okay, so for the sake of your practice, I want you to deal with this question: 2x plus 1 over x to the power 10. I want you to find or expand up to, let's say, first 6 terms. Okay, show the first 6 terms of that expansion. So you start from 10 choose 0 all the way up to 10 choose 5. That's fine. Okay, so that would be a good start for you.